Hello and welcome back to Pre-Algebra with Miss Betsy. Today we are talking about how to solve equations when we have variables on both sides of that equation. For those of you who are tracking with me, I am using as my text Pre-Algebra for Christian Schools. It's published by Bob Jones University Press and I am using the first edition. Before we get started, I have a lame joke. I'm not sure if I've told this one before or not, but I want to know if you can tell me what you get when you cross a dinosaur and a dog. Well, you get a very nervous mailman. So let's go ahead and dive right into our work. We are on chapter 8.6, page 266, solving equations where we have variables on both sides. This is example 1 on page 266, and that is not the marker that I intended to pick up, because the red one is not good anymore. Example 1, page 266. We want to solve and check 7x is equal to 16 plus 5x. When you first begin to work with equations that look like this, where you have a variable on both sides of the equal sign, sometimes you think, I can't do that, because I have to be able to collect like terms and they're on opposite sides of the equal sign. Well, all you need to do here as a part of isolating your variable is just apply whatever inverse operations you need to, so that you can have all of the variables on one side of the equation, all the constant terms on the other side of the equation. And our brains have just gotten used to the way that we write algebra, where frequently we have the variable on the left-hand side of the equation. Doesn't have to be that way, but we're going to solve this equation so our x values are on the left-hand side and our solutions on the right. So what's going on over here? Well, we have a plus 5x. In other words, 5x has been added to the right-hand side of the equation. The inverse operation to addition is subtraction, so we are going to now subtract a 5x from both sides of the equation. We have to make certain that we subtract that from both sides so that our equation stays in balance. Like terms, you subtract the coefficients. 2x is equal to 16. X has been multiplied by 2. The inverse of multiplication is division. So we are going to divide both sides of that equation by 2. 2 divided by 2 is 1. We have x is equal to 16 divided by 2 is 8. Now we have to check and make sure that we end up with a true solution. How do we do that? Yep, you just take our answer, substitute it for the variable in our initial equation. So we're going to say check 7 times 8, is that equal to 16 plus 5 times 8? Not 5 times 80, it's definitely not equal to 5 times 80. The question mark above the equal sign means, does it equal or is it equal to? 7 times 8, 56. Is that the same as 16 plus 40? Yes, of course it is. 56 is equal to 56. This is just the same sort of information that we've been working on all year long, for the last bit of time since we've been working with solving equations. Let's go ahead and do example 2 now, which is a little bit different. Not a lot, but a little bit. We have 2x plus 9 is equal to 5x minus 3. 2x plus 9 is equal to 5x minus 3. When we did our first example, we manipulated the equation so that our x term was on the left-hand side. But equations that are in balance are the same regardless of which way you look at them. Okay? So we could just as easily solve for our variable, have our x on the right-hand side of the equation. And that's what they're going to do. They're choosing to put the constant term on the left, put our variable on the right. And there's a reason, actually, that they've decided to do that. We have 2x and 5x. If you will isolate your variable on the side of the equation where you have the greater variable, the coefficient is larger over the variable, that will eliminate the need to deal with the negative. So if we want to isolate our variable on the right-hand side, we're going to subtract a 2x from both sides of the equation. 5x minus 2x minus 3. And you saw that I just stuck those right there in the middle. It's because subtraction, when you subtract a number, you're adding the opposite, correct? So addition is commutative. The order doesn't matter. I just automatically default to adding or subtracting variable terms, terms or constant terms, by putting them right next to where I'm going to subtract. See, 2x minus 2x, 0. So I have 9 is equal to 5x minus 2x. You subtract the coefficients, 3x minus 3. We're going to solve so that our x is on the right-hand side of the equation. So what's been going on here? We've subtracted 3. Inverse is addition, so we're going to add 3 to both sides of the equation. 3x minus 3 plus 3. 12 is equal to 3x. X has been multiplied by 3, so we are going to divide both sides of this equation by 3. And we see that we have 4 is equal to x, or x is equal to 4. What do we do to check this? Take our value of 4, substitute back into our original equation. Let's go ahead and do this. Let me see if I can get over here for our check. 2 times 4 plus 9, is that equal to 5 times 4 minus 3? Carry out your arithmetic. 2 times 4 is 8 plus 9. Is that equal to 20 minus 3? Yes, 17 is equal to 17. And we have checked or verified for ourselves that when we assign x a value of 4, we have a true solution. Okay? And that is really all there is that you're doing in this section. May take you a little while to get comfortable working on these, but the more you practice, the more readily you'll be able to recognize the steps that you take, and the less opportunity you will have to make an error. This was so quick. Let me go ahead and see. Let's go ahead and talk through 4 of these problems here where we to see what we would want to do to get the variable on which side of the equation we'd want the variable to be placed onto. If I have 7c is equal to 16 plus 4c. The next one I have is 4x is equal to 12 minus 2x. Next, I have 3n plus 5 is equal to 8n, and 4, I have 5y minus 24 is equal to 9y. And what they're asking us to do in this skill check portion of our homework section is, first, which side of the equation do you want your variable to be on? It can be either on the left-hand side or the right-hand side. And in case you didn't catch what I said in that last problem that I worked, if you will look at the variables on both sides of your equation, one of those variables is going to be larger than the other. The coefficient is going to be larger. 7 is greater than 4. If you will move, or if you will isolate the variable on the side of the equation where its coefficient is larger, it will make your arithmetic just a little bit easier. 4 is greater than a negative 2x, than 2. 8 is greater than 3, so we're going to move this way. 5 is less than 9, which means 9 is greater, so we're going to move in this direction. Watch what I mean. What are we going to do? We're going to subtract a 4c. Let's see what happens if we do that. 7c minus 4c is equal to 16 plus 4c minus 4c. 3c is equal to 16. C is equal to 16/3. We subtracted a 4c from both sides of the equation. 7 minus 4 is 3. Divide both sides of the equation by 3. You end up with 16/3. Now let me show you what would have taken place, what would have happened had we moved. Actually, I'm going to wait and show you when we get down here. So what did we do to move the 4c, to eliminate 4c? We subtracted 2. We subtracted 4c. What do we need to do to isolate the variable on the left-hand side of the equation? In this second example, we want to isolate the variable on the left. So what are we going to do? We're going to add 2c to both sides of the equation. What happens if we add 2, it's not c, is it? Add 2x. 4x plus 2x, 6x is equal to 12. Negative 2x plus 2x eliminates our variable on the right-hand side of the equation, and you divide both sides of this equation by 6, and you end up with x is equal to 2. Now, however, the smaller coefficient, smaller variables on the left-hand side, so we're going to isolate the variable on the right-hand side of the equation. If we want to get rid of this 3n, what do we need to do to both sides of the equation? You need to subtract 3n from both sides of the equation. 3n. 3n minus 3n is 0. You have 5 is equal to 8n minus 3n. 8n minus 3n is 5 times n. In order to solve for n, you divide both sides of this equation by 5, and you have n is equal to 1. Now this right here is the one that I want to use to illustrate to you the reasoning behind, that lies behind isolating the variable on the right-hand side of the equation. Let's say that we just wanted to isolate it on the left-hand side. Can you do that? Sure, nothing wrong with it at all. What are we going to have to do so that we don't have any n's on the right-hand side of the equation? Well, we are going to have to subtract 8n from both sides of the equation. Plus 5 is equal to 8n minus 8n. We had a positive 8n, so we subtract 8n from both sides of the equation. 3 minus 8, we have negative 5n plus 5 is equal to 0. We know we have to have the constant term on both sides of the equation. We've added 5. Inverse of addition is subtraction, so we subtract 5 from both sides of the equation, which gives us negative 5n is equal to negative 5. Now we're going to divide both sides of this equation by a negative 5, and we have n is equal to 1. By isolating the variable on the right-hand side of the equation here, you eliminate any need to deal with negative signs, and we frequently lose negative signs when we're beginning to learn how to do algebra. So as long as you can be comfortable keeping your equation in balance, red left to right, or right to left, if you will, having your variable on either side of the equation, it can be less dangerous to solve it this way. Our final problem here, this is supposed to be a 9y. We have 5y minus 24 is equal to 9y. The coefficient here is larger, so we're going to eliminate the 5y. It's a positive 5y, so we'll subtract 5y from both sides of the equation. Is equal to 9y minus 5y. No? Yes, 9y minus 5y. Negative 24 is equal to 4y. We'll go ahead and divide both sides of this equation by 6. Negative 4. Why did I say 6? You know why I said divide by 6? Because I had gone to my answer. We're going to divide both sides of this equation by a positive 4. 4 divided by 4 leaves us y is equal to a negative 6. So there, I went ahead and gave you several more examples so that you can go through and see exactly how we are manipulating our equation so that we have the variable on one side, the constant term on the other. Take as much time as you need to make certain that you understand what's going on. I'll see you next time.